Okay, we're looking at direct and inverse variation equations and also the application. So an equation that has a direct variation, let's say x varies directly with y equals a constant in times y. X varies directly with y. We'll give the equation x equals a constant times y. If it was inversely, x varies inverse with y, this will be x equals the constant over y. Okay, so we're going to look at developing these equations. So, number one, the distance varies directly with the speed, while the speed is 60 miles per hour. What is the distance? What will the distance be if the speed is 50 miles an hour? So, we're talking about the distance. We'll use d for distance. Varies directly with the speed. So equals k times the speed. We'll use s. So distance and speed. Further, we find that the distance traveled is 50. I guess it's 50 miles. And at a speed of 60. So that's k times 60. So we get a distance of 50 miles with a speed of 50 miles an hour. I'm going to solve for the constant here by dividing both sides by 50. Sorry, that's 60. And let's see, the zeros cancel. We get 15 over 6. And let's divide both sides. 3. And we get a constant of 5 over 2. Okay. With this constant, we can replace it back in here and now say that d equals the constant 5 over 2 times the speed. Furthermore, we find that the question is, what is the distance if the speed is 50 miles an hour? So, what is the distance with the constant of 5 over 2 and a speed of 50 miles an hour? I'm going to put a 1 under that 50. So what we get is 50 over 1. And I would simplify these two. This will become a 1, and this will become 25. And now it becomes 5 times 25, which is 125. And your distance is 125. Okay. Number 2. The price varies inversely with the demand. The price is $250 while the demand is 100 orders. How many units will be demanded if the price is $200? So price varies inversely with the demand. So we use P for price. Varies indirectly with the demand would be K, our constant, over we use D for demand. So that's the inverse relationship. Furthermore, we're told that the price is $250 when demand is 100 orders. So let's put $250 for the price, and let's put 100 orders here. So if we solve for K, I multiply both sides by 100. The 100 is canceled here, we get K. And when I multiply this, we get 2, 5, and 3 zeros. So 25,000. So K becomes P equals 25,000 over demand. And that's our inverse equation. The question now is, how many units will be in demand if the price is $200? So we need to put $200 in for the price and find out what the demand is. Okay. So I'm going to multiply both sides by D, which is the denominator here. We'll get 200D, and the D's here will cancel. We'll get 25,000. Dividing both sides by 2. We get D here. Those zeros cancel, and we're left with a 250 over 2. Half of 2 is 1. Half of 5 would be 2. Half of 10 would be 5. So the demand will be 125. Okay, number 3. The area of a circle varies directly with the radius squared. The area is 6.75 centimeters squared, while the radius is 1.5 centimeters. What will the area be if the radius is 2 centimeters? Let's see. Area of a circle varies directly with the radius squared. So it's K, and that's a radius, but the radius is squared. The area is 6.75. Okay, whereas the radius is 1.5. Okay, so we're going to find the K here. This is 6.75, and 1.5 times 1.5 will be 2.25. Now divide both sides by 2.25. And I can see that 2 goes into 6 3 times, and 25 goes into 75 3 times. So K is 3. So what we have here is that A is equal to 3 times the radius squared. Okay. That's our variation equation with the constant placed in. Furthermore, we're asked, what will the area be when the radius is 2 centimeters? So what will the area be when the radius is 2 centimeters? Well, this will be 3 times 2 squared is going to be 4. So that's times 4. And the area will be 12 centimeters squared. Number 4. To preserve the volume inside a cone, the height must vary inversely with the radius squared. The height is 10, while the radius is 2 feet. That should be 10 feet. What will the height be if the radius is 1 foot to preserve the volume? Okay, so we're preserving volume by using the variation equation. To preserve the volume, the height must vary inversely with the radius. So height equals K over radius squared. Okay. So that's what we're calling to preserve the volume. So we're told that the height is 10 and the radius is 2. So when I square this, I'm going to get K over 4. Then I multiply both sides by 4. So we get 40 equals K, which implies that the height is equal to 40 over r squared. Furthermore, what will the height be if the radius is 1 to preserve the volume? Okay, so the height will be 40 over radius of 1 to the second power. 1 to the second power is still 1. 40 divided by 1. So we'll have to change the height to 40 in order to preserve the volume, whereas before the height was 10, if the radius was 2.